So hey nerds, this is Suman and hey Electroboom. I hope this video will reach up to you in some days, some years, or some centuries. I don't know, but one day I guess so. This video will reach up to you, and you are the one whom I used to follow from my old days, just to learn about the electronics, right? And I'm actually from Nepal, and I had made a video about uh, how the how the Stark shift can be done by using classical theory. So I do not have actually research equipments and facilities, fields, like things in my country, so that I am making this video, and I hope this video will reach up to you, and you will make a better you will give the better feedback in my idea. And whether it works or not, I don't know, because I want to share it to the people, and people also acknowledge it, right? So by saying this much, I'm quitting. Thank you. So notes, before starting the classical idea of Stark effect, let us understand what actually the Stark effect is. So let us assume this is an atom, or you have an atom here, and you put an atom in an external electric field. So what will happen? There will be some shift in energy, because there is some energy associated with the field, right? So, and when you excite that atom from lower energy state to a higher energy state, and it comes back to lower energy state, then it will emit a radiation, right? And scientists have thought that there might be the single spectrum, there would be the single photon emitted, but rather they have seen multiple spectrum. So this kind of blows their mind, what is happening over here. So I came up with the idea that explaining how this splitting of spectrum is actually done, and relation that might holds true, how the frequency will shift in a particular orbit with respect to electric field. So let us dive into the whiteboard. So in order to do the classical theory of Stark effect, we are assuming that the particular hydrogen atom, for our simplicity, right? And we apply a potential difference across it. So when the electron would be here, electrostatic force is acting upon it in that direction, right? And the nucleus is also exerting some nuclear force in this direction. Let's say this is Fen, that means electrostatic force due to nucleus, right? And when the electron is revolving, or during its motion reaches up to here, the electrostatic field would again be in same direction, and the nuclear force would be again in same direction, right? The nuclear force would be in this direction, and electrostatic force is supporting in that way. So you can make a beautiful assumption here that the electrostatic force in somehow in this scenario is opposing the nuclear force of nucleus. And when the electron is in this particular moment, the nuclear force and the external electric field is actually in support of electrostatic force due to nucleus. So you can make a beautiful assumption that the net force acting upon, so the net force, so you can actually see the net force, if I make a free body diagram, could be the electrostatic force due to this external field could be in this direction, right? Could be in this direction, or could be in this direction, right? So from this perspective, the electrostatic force is opposing. From this perspective, the electrostatic force is actually supporting. Now the electrostatic force could be either in both scenarios, it will be in upward direction, but from here it is opposing its field, and from here it is supporting. So the net force acting upon that charged particle would be, so the net force is the electrostatic force due to nucleus plus or minus the electrostatic force due to this external field. We are using Fe as external field, and this will slightly change the angular velocity of particle. omega plus d omega, this small quantity, right? So at equilibrium, if you know, if the electric field is removed, and the new electron is moving in this particular orbit, the electrostatic force would be equal to centripetal force, right? So the electrostatic force can be replaced as mr omega square, because there is no shift in velocity if there is no external electric field. Okay, so you can replace electrostatic force as mr omega square plus or minus. I am using plus or minus sign because the electrostatic force, external electrostatic force, could support the nucleus electrostatic force, or the external electric field might oppose the nucleus field, as you can see here, right? So, and this would be nothing but charge and electron time, how much electric field you are applying in that particular atom. So I am using E vector for our better convenience, because we are going to use the energy term also E here, so you might not get confused. And this is mr, and if you open this whole square term, 2 omega d omega plus d omega square. So the omega is very small quantity. Suppose it is 0.001, and if you square this, it will again end up getting a very small quantity, so you can neglect it as 0. So what we will left, mr omega square plus minus E vector mr omega square plus 2 mr omega d omega. So you can cancel out this, because this term will cancel out each other in every case, because the electrostatic force is always balanced by the centripetal force. Now the centripetal force is due to the cause of electrostatic force of attraction between two charged particles, right? So, and we will end up getting plus minus E vector, and this is 2m. This r omega is nothing but the linear velocity of particle, and the d omega. So can you tell me what the d omega represents? This is the shift in angular velocity of particle in that particular orbit. So plus minus E vector, and this is 2mv. So you can replace omega as 2 pi times frequency. So the 2 pi cannot be changed because it's a constant, so there will be change in some frequency. So plus minus E vector equals 4 pi mv, and this would be df. There will be small change in frequency of electron during revolution in that particular orbit. So I am just plus minus E vector by, you can write it here 4 pi mv and make df alone. So I am multiplying both sides by df, because as I have already done in my earlier video how I have explained classical Zeeman effect. I am multiplying both sides by h, so I have to write here also h. So why I am doing this? Because I have a great assumption that the electron follows Planck's radiation law. The electron energy can be replaced by equivalent Planck's radiation energy. So the total energy of electron is negative, so I am using negative sign here, and this will make here minus plus, right? And this is E, the shift in energy due to electric field would be minus plus EH upon 4 pi m E vector by V vector. So this is the energy term, and this is the electric field. So I have used the vector sign here. I am not doing anything wrong, because I want to convince you that the E and this E are different quantity, right? So dE can be replaced as minus plus, and this whole term can be represented by Bohr's magneton, a constant quantity. So this is E vector upon V. So this would be the energy shift due to electric field in an atom, right? So I am running all these portions so I can do some more little bit of maths. So I know the Bohr's idea. There is a Bohr's great idea. From Bohr's idea that when you apply electric field in that atom and you excite the electron in a higher energy state, and when it comes back to the lower energy state, it emits a photon. But in Stark effect, there will be multiple splitting of lines. So E2 means higher energy state minus lower energy state gives you a photon. So I am using F for frequency of electron, and this is nu, NEU, nu for frequency of photon. So if I differentiate both sides, I will end up getting dE2 minus dE1 equals h, and this would be the shift in frequency, right? So using this, you can put your values here. So if you put E2 here, you have to use V2 velocity, and if you use E1 here, you have to use V1 velocity. And you can ask me why the electric field is not used, you are using E2 and E1, because the field strength is constant over the time. You are applying the same field. So you can write here dE2 is minus plus mu B. So I'm using now E for electric field upon V2 minus plus minus mu B E upon V1 equals h d nu of photon, right? I'm not doing anything wrong, I guess so. And h d nu of photon equals minus plus mu B, and you can take common mu B E, right? And this would be 1 upon V2 minus 1 upon V1. So d nu can be represented as minus plus mu B E upon h, and this is nothing but V1 minus V2 by V1 V2, right? And the frequency shift would be plus minus, or you can say minus plus or plus minus, it doesn't make any sense. And you can write it as change in velocity by product of two velocity, the velocity in first orbit and velocity in second orbit, and this is the change in velocity of first orbit with respect to second, right? So this will be your result. So the change in frequency of photon depends on the change in velocity of electron, how much the velocity is changing over during the transition of electron from higher energy state to the lower energy state. So this will be the better result, I guess so. And if you watch my idea that you have end up here, and now we can use some beautiful assumption that I'm drawing this portion here, and what I'm getting here is so I'm doing something very much beautiful. I want to replace this equation in terms of magnetic field. So I'm taking this portion, or simply this portion, and if I have E here, I can make E here also, right? So h d nu of photon can be replaced by minus plus mu B, and this is E upon V2 minus E upon V1. So d nu of photon can be replaced by minus plus mu B upon h. So if you know the idea that the ratio of, we can represent velocity as a ratio of electric field upon magnetic field, right? So we can write magnetic field is E by V. So for a particular orbit, so for V1 orbit, there will be V1 velocity, V1 magnetic field, and for V2 orbit, there will be like this equation. So you can replace E upon V2 by V2 minus E upon V1 by V1. So this would be the change in frequency is nothing but minus plus mu B upon h delta B, or you can write dB. So you can ask me why I am using that magnetic field, because we are not applying any external magnetic field, but I am writing magnetic field because I can write this equation in terms of equivalent magnetic field. The ratio of these terms came out to be the magnetic field. You can replace this ratio has the unit of Tesla. So you can replace this ratio by equivalent magnetic field and this ratio by equivalent magnetic field in second orbit. So does my assumptions are correct? Does this equation is dimensionally correct? You can ask myself. So the unit of Bohr's magneton is joule per Tesla, right? And the ratio, Planck's constant is joules second, and the magnetic field is nothing but Tesla. So the Tesla will cancel out, the joules will cancel out, and you will want getting 1 upon second. And this is the frequency. 1 upon time period is nothing but the frequency. So dimensionally it is correct. So this was my idea. See you in next video.